Good day everybody, we have been given this question. If interval 0 to 1 dx over 5 positive 2x negative 2 times x squared f is equal to 2 over alpha of 2 over alpha times ln of alpha positive 1 over beta, then we are asked to find alpha raised to the power of 4, beta raised to the power of 4 divided by 7 is equal to what? So let me consider integral 0 to 1 dx over 5 positive 2x negative 2x squared. Now I would like to take negative 2 out, so I would get x squared negative x and then negative 5 over 2, and you have dx there. 0 to 1 is the limit. Now I can rewrite this as negative 1 over 2 integral dx over x squared negative x negative 5 over 2. I want to rewrite this entire quantity as a perfect square. So can I write it like this? X negative 1 over 2 whole squared. This would give me x squared negative x positive 1 over 4, but I need a negative 5 over 2. So what I would do is I would subtract 11 over 4. Because if I were to do that, I would get negative 10 over 4. 2 divides here 2 times, 2 divides here 5 times. So this is fair enough. But when we write, I would be rewriting it as negative root of 11 over 2 whole squared. So this is equal to negative 1 over 2 integral dx over x negative 1 over 2 whole squared negative root of 11 over 2 whole squared. Okay. Now this is likened to the standard integral dx over x squared negative a squared, which has a formula 1 over 2a ln x negative a divided by x positive a positive c. That's a formula. So this is going to be negative 1 over 2. 1 over 2 times my a is root of 11 over 2 ln modulus, limits are 0 to 1, ln modulus x negative 1 over 2 negative root of 11 over 2 divided by x negative 1 over 2 positive root of 11 over 2. The limits are 0 to 1. Now 2 gets cancelled, you got negative 1 over 2 times root of 11. I'm going to substitute the upper limit. If I substitute 1, I would get 1 negative 1 over 2. And that's going to be 1 over 2 negative root of 11 over 2 divided by, I substitute 1, I would get 1 over 2 positive root of 11 over 2. Okay, this is for the upper limit minus the lower limit ln modulus. I substitute 0, I get negative 1 over 2 followed by negative 11 over 2 divided by, I substitute 0, I get negative 1 over 2 positive root of 11 over 2. This is what I get. Okay, now I want to get rid of this modulus. Now root of 11 is greater than this quantity 1, right? So because of this fact, I can, what I would say, before I could apply this, I can cancel this 2 out and I would get negative 1 over 2 times root of 11 ln modulus. It is going to be 1 negative root of 11, right? This 2 and this 2 gets cancelled, giving me 1 positive root of 11 followed by negative ln. Now you have a negative that can come out, and this would be 1 positive root of 11. The 2 goes off, and this is going to be negative 1 positive root 11. So let me write that, negative 1 positive root 11. So this is what I've got. Okay, so as I mentioned to you, I want to get rid of this modulus. Now, to get rid of this modulus, as I mentioned to you earlier, root of 11 is greater than 1. So I would rewrite this as root of 11 negative 1 divided by root of 11 positive 1. That's you have nothing to do there. So this is what we have got here. This is equal to negative 1 over 2 times root of 11 and followed by a negative sign. Now this one you have nothing to do in this case, so this is going to be just a root of 11 positive 1. Now as I mentioned to you, I would rewrite this. If I were to take a negative sign out, I would get root of 11 negative 1. So this can be rewritten like this. Because of the presence of the modulus sign and to the fact that root of 11 is greater than 1, I am in a position to write it like this. Right? So the modulus sign comes to our rescue. So having got up till here, I will be utilizing this formula ln A negative ln B, which is equal to ln of A over B. So this is equal to negative 1 over 2 times root of 11 ln of, I will write it as root of 11 negative 1 divided by root of 11 positive 1 divided by root of 11 positive 1 divided by root of 11 negative 1. Okay, so this is ln of A over B, so you can flip this and rewrite this as negative 1 over 2 times root of 11 ln of root of 11 negative 1 divided by root of 11 positive 1 multiplied with root of 11 negative 1 divided by root of 11 positive 1. Okay, you see the terms are like in nature. So this is negative 1 over 2 times root of 11. You can multiply these two things and get the following. What is that? That's going to be root of 11 negative 1 divided by root of 11 positive 1. This is raised to the power of 2. Now ln of A over B is equal to B times ln A. So this will give you negative 1 over 2 times of root 11 times 2 times of ln of root of 11 negative 1 divided by root of 11 positive 1. Okay, so 2 gets cancelled, giving you negative 1 over root of 11. Now I would like to that is going to give me root of 11 negative 1 multiplied with root of 11 positive 1 divided by root of 11 positive 1. So in the denominator you have root of 11 positive 1. Okay. So now, excuse me. So this is negative 1 over root 11. Excuse me. Ln of, now we can utilize this formula A negative B multiplied with A positive B. This would give you A squared negative B squared. So utilizing this, I would have root of 11 squared negative 1 squared divided by, now this is A positive B multiplied with A positive B. That would give us A positive B whole squared. So this is going to be root of 11 positive 1 whole squared. So this is rewritten as negative 1 over root 11 times ln. Now root of 11 squared is going to be 11, right? Square root goes away, minus 1 divided by root of 11 positive 1 raised to the power of 2. Now this quantity 11 minus 1 is going to be 10, right? So this is negative 1 over root 11 ln 10 divided by root of 11 positive 1, the whole square. Right. Now, if I were to flip this, I can rewrite this as negative 1 over root 11 ln of root of 11 positive 1 divided by 10. This is raised to the power of 2. But since I have changed the orientation, this will become negative 1. So let me write like this, negative 1. Okay, so there's a formula, ln a raised to the power of b is equal to b times ln a. By that formula, I can bring this negative over here, that will become positive. So it's going to be 1 over root of 11 ln of root of 11 positive 1 raised to the power of 2 divided by 10. Now I'm going to rewrite this as 1 over root of 11 ln of root of 11 positive 1 divided by root of 10. This is raised to the power. This is raised to the power of 2. Okay. Now, as I mentioned to you, we will be utilizing this ln a raised to the power of b is equal to b times ln a. So this is fair enough, right? Root of 10 squared is nothing but 10. But we already have root of 11 positive 1 raised to the power of 2. So that's why I'm writing it like this. So this is going to be 2 times root of 11 ln of root of 11 positive 1 divided by root of 10. Now clearly this is of the form 2 over alpha ln of alpha positive 1 divided by beta. So this means my alpha is equal to root of 11 and my beta is equal to root of 10. So therefore alpha raised to the power of 4 negative beta raised to the power of 4 divided by 7 is equal to, in place of alpha you have root of 11 raised to the power of 4 negative root of 10 raised to the power of 4 divided by 7. So let me go over here. So this is equal to, now this is what we've got, right? Root of 11 raised to the power of 4 negative root of 10 raised to the power of 4 divided by 7. Now there is a formula, a raised to the power of m whole raised to the power of n can be rewritten as a raised to the power of m times n. Also a raised to the power of 1 over m raised to the power of n can be rewritten as a raised to the power of n over m. So by this formula I can rewrite this. This is nothing but 11 raised to the power of 1 over 2 raised to the power of 4 negative 10 raised to the power of 1 over 2 raised to the power of 4 divided by 7. This is nothing but, by this law, this is 4 over 2 negative 10 raised to the power of 4 over 2 divided by 7. Now 2 divides here 2 times, so 11 raised to the power of 2 negative 10 raised to the power of 2 divided by 7. This is 121, this is 100, this is 7. So you get 21 divided by 7, 7 divides here 3 times. Therefore alpha raised to the power of 4 negative beta raised to the power of 4 divided by 7 is equal to 3.